So this is a steps for creating decorator. After creating decorator, next is so applying decorator. Applying the decorator. So decorator is applied. Decorator is applied to another function. Decorator is applied to another function. So what is the syntax of applying decorator is at the rate decorator name. So decorator name is nothing but this function name. This is called as function name, or same thing you call it as decorator name. So at the rate decorator name, and this is a function to which you are, this is a function which you are decorating it. This is a function which you are decorating it, and you are trying to include the statements. So for working with the decorators, what is a decorator? Decorators are special function. A decorator is a special function which is used to extend the functionality of existing function. Decorators are special functions which are used to extend functionality of existing function. And decorator function receives input as a function and return extended function or new function as an output. Return new function or extended function as a output. So working with the decorators require two steps. One is creating decorator and one more is applying decorator. So generally decorators are used for function transformation. Decorators transform one function to decorators transform one function to one function to what here another function. So decorators, you can use it so decorator transform okay, decorators transform decorator transform one function to another function. Then means function transformation function transformation is done by using which one here? Decorators. Function transformation. You are trying to transform one function to another function. That is done by using decorators. Now this is Python definition of decorator. What is decorator means? A function returning another function, usually applied as a function transformation using the wrapper syntax. Now these are predefined decorators provided by Python. So that is what class method and static method. So these are some of the predefined definitions. Okay, so these are predefined definitions. A function returning another function. This is another definition for this. A function returning another function. A function returning another function. This is also one definition. Usually applied as a function transformation using wrapper syntax. Common examples for decorators are class method and one more is which one here? Static method. Class method and one more is which method? Static method. So creating decorator and one more is applying decorator. See, it's as simple as like this. I said extending the functionality of existing function. Our function transformation is done by using decorators. For example, there is one function already exists. Assume that there is one function. Assume that there is one function. Suppose there is one function called function 1. There is one function which is already written. What is the name of the function? Function 1. I want to transform this function 1 into another function without modifying this functionality. I want to transform this function into what? Another function without modifying the functionality. Then what do you do it? You write another function. You write another functions here. This is another function. What is this another function here? Decorator. What is this function here? Decorator. To this function, you send this function as what here? Input. Because you want to transform this function to what? Another function. Then you are sending this function 1 as the input to which function? Decorator. And within decorator, you transform this function by writing another function. Inside the decorator, how you are transforming the function? By writing another function. So what is that another function here? Function 2. Inside the decorator, you are transforming this function 1 to which one here? Function 2. You are transforming the function 1 into function 2 and returning which function here? Function 2. It means function 1 is transformed to which function? Function 2. I mean, function 1 functionality changed to what? Function 2. So that you are saying it, that you are doing it with the help of which one? Decorators. So it allows to extend the functionality of the existing function without modifying. It allows to extend the functionality of existing function without modifying it. So it takes the input as a function. What is the input you are giving here? Function. And what is the output it is giving? Another function. And this function is called which function here? Transformed function. Okay, this function is called as which function here? Transformed function. So what is this function here? Transformed function, which is nothing but a new function, which is changed. Function 1 is changed to what here? Function 2 by adding some new features. Function 1 is changed to function 2 by adding some new features. Function 1 is changed to function 2 by adding some new features. So that is done with the help of what here? Decorators. Okay. That is done with the help of decorators here. So there are two steps are there. One is one is creating decorator. What is the first one? Creating decorator, and second one is applying the decorator. How many steps are there? Two steps are there. One is creating a decorator, and one more is what? Applying the decorator. Creating decorator is one, and applying decorator is what? Another. So two steps are there. Now decorator takes the input as one function and return the output as what? Another function, and that is called which function here? Transformed function. That is called as which function? Transformed function. So for example, there is one function. Okay, there is a function called display. So simple example, there is a function called which one here? Display. And display is a function which displays a message saying like some Python, display the message called Python programming. So display is a function which display one message. Okay, display is a function which display the message. What is the message it display here? Python programming. Display is a function which display the message. So display function, what message it display? Python programming is a message. It will try to display the message called Python. Programming is a message. Okay, right now this is a simple function here. So what is the name of the function here? Display is a function which is trying to display the message. So what is the message it is displaying? Python. Programming is a message. Okay. Okay, fine. So this is a normal function. Okay, now I want to decorate this. Now see, if I run this program, I'll get the message. If I run this program, I'll get a message. So what is the message I'll get is Python programming is a message. So my program execution starts from where? Main, which is called as executable statement. And this main function calls which function here? Display function. This main function calls which function here? Display function. And display function is trying to display a message. This main function calls a display function, and display function is trying to display the message. What is the message is trying to display? Python program. It's trying to display the message. What is the message is trying to display? Python programming. Okay, yes. Now I want to decorate this. I want to transform this display. I want to transform this display to another function. Then suppose I want to decorate this. So I'm trying to write one decorator. I said decorator is a function which receives the input as what? Another function. Okay, suppose there is a decorator called, there is one decorator called which one? Draw line. Now draw line is a decorator, and draw line is a decorator which receives the input as what here? Function. Draw line is a decorator, and this decorator receives the input as one function. This will receive the input as one function. So decorator must have one argument. Decorator must have one argument. Decorator is a function, right? Now this function should have one argument, and this is one argument, right? So decorator receives the input as one function. And inside this, you're transforming the function into another function. So this is transformed function, which is called as some new display. New display. It means I'm transforming this display to which function here? New display. Now here you are modify or extend the functionality of display. So what I'm doing is I'm trying to draw the line here. Okay, saying star into some 40. Then called a function called f. F is nothing but I try to include the functionality of old function. I try to include the functionality of which function? Old function. This f is nothing but old function or transformed function. Okay. Then what I'm doing is I'm trying to display again print. So what I write here star, I want this star should be repeated how many times? 40 times. And then I said new display. So in order to work with the decorator, you require two steps. One is writing the decorator, and one more is applying the decorator. Two steps are there. One is writing the decorator, and one more is what? Applying the decorator. One step is writing and second one is what? Applying. It means draw a line. So you are trying to decorate this display with one decorator. What is the name of the decorator here? Draw line. So actually what you are doing, you are calling the function display. But display, when you call display function, internally your Python calls which function? Draw line. By sending which function here? Display function. And then the display function, see, I send which function? Display function. Means f is a argument, and this argument hold the address of which function here? Display function. This f is the argument, and this argument hold the address of which function? Display function. If I'm writing here f is referring to which function here? Display function. Means you are calling which function? Display function. Okay, and this display function print Python programming. So what is the output of this f here? Python programming. But this Python programming, how it will display? This Python programming, how it will display? Within the stars. So here I try to extend it within the stars. So here I try to extend what here? Functionality within the stars. So this is where within the stars you're trying to display that. So there is one star and there is one more star here. So within the stars you are trying to display. Okay, after that again it will try to draw one more stars. So this is how you are trying to display. It means you are calling display function, but Python will call which function here? New display function. But this new display function printer, what it print here? Stars. And included functionality of which function? Old function. Included functionality of which function? Old function. And again I draw the line and return which function here? New function. And return which function here? New function. So what will be the output of this is? Now decorator is a special function, and this function receive the input as one function and return output as another function. You can see it is draw the lines and Python programming and again draw which one? Line. Okay, so but actually you are calling which function here? Display function. But display function is decorated by using which function? Draw line function. You are calling display function, but display function is decorated using which function? Draw line function. And this draw line function receive the input as which function? Display function. And returning which function? New display function. What new display function is doing? It is drawing the line and calling which function? Display function. And again it is drawing which one? Line. So transforming, function transformation is done by using decorators. This is simple example. This is a simple example of writing the decorator here. But this is done by using nested functions. This is done using which function again? Nested functions. So this is where again nested functions are useful. This is where again which functions are useful? Nested functions are useful here. Suppose I'll tell you another function here. Now it is extending the functionality of existing function. For example, there is a function called division. There is a function called what here? Division. Division is a function. And this function receives the input as two values. One is A and one more is what? B. And the C equal to A divided by B and returning value of which one here? C. Division is a function and this function takes the input as how many values? two values. One is A value and one more is what? B value. After receiving the input, it will do which operation? Division, and then return which value? C value. Fine. Suppose, assume that you are trying to call result 1 equal to division. I try to send 5 comma 2. Okay, result 1. I try to send how many values here? 2 values. So yeah, the value of A is a 5 and the value of B is what? 2. The value of A is a 5 and the value of B is a 2. And you are trying to say C equal to A divided by B. That is 5 divided by 2 is what? 2.5. And it will return the value of C, which is 2.5. Okay, fine. Okay, fine. Now if I run this division, so if I run this, what is the result? It is displayed 2.5. Okay, the result of this division is what here? 2.5. So how many inputs are given here? Two inputs. The value of A is a 5 and the value of B is what here? 2. How many inputs are given? Two inputs are given. The value of A is a 5. The value of B is a 2. So after division, you are trying to display what here? Result. Okay. So once you run this, what is the output is given? 2.5, right? 5. Suppose, okay, suppose if I'm writing result 2 equal to division and I try to input two values. So the value of A is given 4. The value of A is given 4. The value of A is given 4 and the value of B is given what? 0. What is the value of A here? 4. What is the value of B here? 0. Can you divide a number with 0? No. So this will give error or not? Yes. This will generate the error. Now, what is the error here? Division by 0. It means this division function is able to divide. This division function is able to divide two numbers, but it can able to divide a numbers whose denominator is not equal to what? 0. If the denominator equal to 0, will it do the division or gives a error? Gives a error. If B value is 0, will it gives an error or not? Yes. If the value of B is 0, it will give what? Error, because you cannot divide a number with what? 0. Then I want to transform this function into another function. So where it will not give any error. Then what I'm doing, I'm writing another function. So without modifying existing functionality, I'm writing another function. And what is that another function is? Some smart division. So what is the name of this function? Smart division is a function which receives the input as what? Function. What is the name of the function? Smart division is a function which receives the input as what? Function. It will receive the input as a function. Which function you want to transform? Division function into which function? Smart division function. So inside this function, you are writing another division function. This is modified function, updated function, A comma B. A comma B, and here you'll try to verify. If B equal to 0, I'm saying return 0. If denominator equal to 0, return 0. Otherwise, you're calling which function? Old function. What is the old function? F. By sending A value and what? B value. So this result, you are returning it. And you are returning transformed function. What is the transformed function here? Division. So I want to convert this division into which division? Smart division. Then I'm trying to use one decorator. And what is the name of the decorator? Smart division. So I convert this division function into which function? Smart division function. I converted this division function into which function? Smart division function. I converted this division function into which function? Smart division. It means what will happen? I'm calling division function. So print result 2. So what I'm doing first, I'm calling which function here? Division function is called by sending 5 as input and 2 as input. But your Python is calling which function here? Smart division by sending which one here? Division function. By sending which function is which function is send here? Division function. And this division, within the division function, there is one more smart division function. There is one function. What is the name of this function here? Division. And this function will verify is it b value 0 or not. So transformed function signature must be same as what? Original function. Because here your division function take how many values? 2 values. And this function should also take how many values? 2 values. Your division function takes how many values? 2 values. Now this division should also take how many values? 2 values. Then if the value of b is a 0, what you are trying to return here? 0. Otherwise, you are calling which function? Division function by sending a value as well as what? B value. By sending a value and b value. So I transform original function into division function into which function? Smart division function. So for that, you're trying to take the help of which one? Decorators. So decorators are wrappers. It means you are wrapping one function inside another function. Decorators are wrappers only, right? Decorator. Generally, decorator meaning is that only, right? You purchase a gift and you try to wrap that gift inside one wrapper. That is called as decorator, right? Okay. Here also, decorators are the function wrappers. It means you are wrapping this division function inside. You are wrapping this division function inside what? Another function. And what is that function? Smart division. You are wrapping the division function into another function, and that you can call it as yes. So this is 2.5 and one more value is what? 0. 2.5 and one more value is a 0. Okay. So this is how you are applying the function or applying the decorator by using which symbol? At the rate symbol. By using which symbol here? At the rate symbol. At the rate symbol you are using it. It is as simple as like this. This is what I say, no? So decorator is a function which takes the input as one function and return output as what? Another function. Takes the input as one function and return the output as what? Another function. For example, a simple example I'm telling you again. So there is one function called, suppose there is one function called A. There is one function called which one? A. So print, this is which function here? A function. Very simple example. This is which function? This is A function. This is which function? A function. And there is another function called which one here? B function. So this is which function here? B function. Two functions are there. One is A and one more is what? B. So this is A function and this is what? B function. This is A function and B function. This is where the decorators exist. So how many functions here? A function is A function display the message A function and B function display the message what? B function. Now I want this both the functions to be transformed. I want this both functions to be transformed into what? Another function. Okay, another function, another function. I want to transform these two functions into another function called which one? C. Then C is what here? Decorator, and which receive the input as what? A function. Okay, C is a decorator. Now this is a decorator function. This is a decorator function which receive the input as what? Function. Then it should return transformed function, right? Okay. So how you are transforming it? By writing another function. By writing which function? Another function. Another function. What is this name of this function here? X. And within X, I'm including the features of existing function. I'm including the features of existing function as well as new function. Existing function as well as what? New function features. Okay, I'm trying to say this is which function here? C function. And return X. So a decorator receives the input as a function and modifying it by writing another function and returning modified function. Okay, decorator is a function which receives the input as one function. Decorator is a function which receives the input as a function, and after receiving the input as a function, that function is modified, writing another function and return which function here? Modified function. Return which function? Modified function. Okay. But how you are decorating it? You are just writing at the rate C. And here also you are writing at the rate what? C. So you try to transform how many functions into C? Two functions. You are trying to transform how many functions into C? Two functions. Now A function, C function, and B function, and what? C function. So is it these are reusables? Once you develop a decorator, that can be applied. Once you develop a decorator that can be applied to one function or more than one function. Once you develop a decorator, the decorator can be applied. Once you develop a decorator that can be applied to either one function or more than one function. So that can be applied to either one function or more than one function. Okay. So it takes the input as one function and return. It takes the input as one function and return output as another function, right? It's very simple. Now, function transformation. If you want to transform some number of functions, for example, you write some 100 functions, and in 100 functions, I want to do some changes. In 100 functions, I want to add some new feature. Then how can I transform that function into other function? I cannot change in 100 functions, right? I cannot add the code in 100 functions. But instead of adding the code in 100 functions, you write one decorator, and to that function use to that decorator you send how many functions? 100 functions, and that will do the changes and return what? New function. That will return what? Here new function. Okay, new function. That will return the new function here, right? So this is how, but this can be done with the help of, which functions? Nested functions. Okay, nested function. Okay. There is one more special function is there. And what is that special function is? Closures. One more special function is there. Python provides one more function. You can develop it. This is called as which one? Closures. Now, what is a closure is? Again, nested function only. What is a closure is? Closure. Closure is a nested function. What is a closure? Closure is a nested function. So closure is a, okay, closure is a nested function which perform operation using, using data of which function? Outer function. Closure is a nested function which performs operation using which function? Outer function. is a nested function which performs operation using outer function. So closer function receive input as a data and return output as what? Another function. Okay. Yes. Closer function receives input as data and return inner function as what here? Output. And this inner function or nested function, this inner function or nested function performs operation using data of which function here? Outer function. Okay, performs the operation using outer function, data of outer function. So what are the steps? Steps for creating which one? Closures. Now, what are the basic steps for creating closures? So first one is define a nested function. Define a nested function. Okay, so outer function receive data. So define outer function. Define outer function which receives what? Data. And define inner function which uses data received by which function? Outer function, and perform operation. Then return which function? Inner function. Return inner function. So these are the basic steps. So basic steps for creating a closure is define a nested function. Define a nested function. Define nested function. Define nested function. Define outer function which receive data. Define inner function which uses data received by outer function and perform operation. Then return which function here? Inner function. Then return which function here? Inner function. So closures are very much useful if you want to perform similar operation on same data. If you want to perform similar operation on what? Same data, then you go for which one? Closures. Even though it is not exist. Means this closures allows you to create new functions. This closures allows you to create what here? New functions. This closures allows you to create a new functions. For example, there is a function called which one here? Power. Power is a function. Power is a function, and this power function receive the input as what? Number. Simple example, power is a function which receive the input as what? Number. So same number I want to find different powers. Same number is the same, but I want to find different powers. Suppose number is a 5. I may find the 5 to the power of 2 or 5 to the power of 4 or 5 to the power of 6 or 5 to the power of 7, like that. So power is a function which receives the input as what? Number. After receiving input as a number, then I should find the power or not. Yes. For this number, I should find out the power. So for that, I'm writing another function which will find which one here? Power. But to find the power for this number, this find power required a power or not? Yes. This find power is required which one? Power. I said closure is a inner function which performs operation using the data of which function? Outer function. So find power is a function which uses number to find out which one power. So here I'm writing return n to the power of p. Return n to the power of p and return which function here? Power function. Sorry. Return which function here? Inner function. And what is that inner function? Find power. So even though execution of power function is completed, even though execution of power function is completed, I can use a data. That data can be used by which function? Inner function, because the data is in user, not in use, in use. For example, I want to find the power of 2. Then I'll say power 2 equal to power. I just call the function by sending 2. So what will happen here is this function is receiving. See, power is a function which receives. What is the value it receives here? 2. Power is a function, it receives the value 2. And after that, it will return another function. What is that another function it returns? Find power. It means power 2 is holding the address of which function? Find power. So power is a function returning which function? Find power function. And find power function. Now power 2 is a variable, and this variable is holding address of which function? Find power. Okay, this variable is holding the address of which function? Find power. Suppose I want to find the power of 2 to the power of. Suppose I want 2 to the power of. What I want is I want the 2 to the power of some 7 or 5. Then I'll say power 2. I'll say power 2 of some 3. What is power 2 here? Power 2 is referring to which function? Find power. Power 2 is referring to which function here? Find power. And this find power receives which one here? Power. What is the value of power here? 3. What is the value of n here? 2. 2 to the power of 3 is what? 8. 2 to the power of 3 is what? 8. So same number. Suppose same number, I want to find out another power. I'll say power 2. Power 2 of which one? 5. Then it will call which function again? It will call which function again? Find power by sending the value of power as what? 5. So that is nothing but 2 to the power of 5. Getting or not? Okay. Some value will get or not. So power 2 will find the power of which one? 2. This function is power 2 function will find the power of which number? 2. Suppose I want to find the power of 5. Then I'll try to create one variable called power 5 equal to power of which one? 5. So what will happen in this case? It will call which function? Power function by sending value of number. What is the value of number? 5. And then return find power function. Return which function here? Find power function. So in this case, find power function is holding n value, right? What is the value of n here? 5. In this case, find power is holding the value of n, right? What is the value of n for power 2? 2. What is the value of n for power 5? 5. So if I want to find the power of 5, then I'll say result 3 equal to power 5. This is nothing but 2. Then what will happen? It will call the function find power and sending the value called which one? 2. This is nothing but 5 to the power of. This is nothing but what? 5 to the power of 2. 5 to the power of 2 is what? 25. Then again I'll say result. Again I'm saying result. Okay, result 4. I'm saying result 4 equal to power 5 of some 4 is nothing but 5 to the power of 4. Suppose I want to find out the 2 to the power of 6. To find the 2 to the power of 6, what I can do? Result 5 equal to which one? Power 2. Power 2 to the power of 6 or not? Yes. I want to find out the 5 to the power of 3. Then what will I do? Result 6 equal to power 5 to the power of which one? 3. Suppose I want to find different powers for which one? 3. Then I create one more function. Now, power 3 equal to power of, what is this here? 3. This function returns the find power that will find the power of which value? 3 value. If I want to find the power of 3, I'll say result 7. Result 7 equal to power 3 of which one? 2. Is nothing but 3 to the power of 2. Okay, so one function is returning another function, but this is an inner function which is doing the operation using a data of which function? Outer function. So I call the power function by sending n, but this n power function receive n and return which function? Find a power function. But this find power function in this call is using which n value? 2. When I say power function by sending 5, it is returning find power function, but in this function call, what is the value of n? 5. I call power function, I called it by sending n value. What is the n value? I send 3 and return find power function, and within this find power function, what is the value of n? 3. It means I created different power functions or not? Yes. So power 2 is a function which finds the power of 2, and power 5 is a function which finds the power of 5, and power 3 is a function which finds the power of 3, but with the different powers or same powers, different power values. Okay, so it is generating number of functions, right, with the same data but different operations. Result 1, result 2, result 3, result 4, result 5, result 6, and finally result 7. Result 6 and result 7, right? So once you run this, I can see 8, 32, and this 25, 625, and 64, and 125, and one more is what? 9. So closure is a function which performs, operation using a data of outer function. Closure is an inner function, but it performs the operation using data of which function? Outer function. It performs operation using data of which function here? Outer function. But this function is returning another function which will perform the operation using the data of outer function, which performs operation using data of outer function. For example, there is one more example. If you see, suppose there is a calculator is there. Now calculator is a function and this receives the input as, calculator is a function which receives the input as, okay, calculator is a function which receives the input as one function. So calculator is there. So what calculator is doing here is, the calculator received two values. Calculator received two values. Okay. This is a calculator which received two values. And on these two values, you may perform different operations. So calculator receive and then return which one? Operator. It will return operator or operation. Okay, operation is it. So what operation it should perform on that values? I'm saying if operator is a plus, then I'm saying return A plus B. Okay, else if operator is a else if operator is a minus, then I'm saying return A minus B. Else if operator is else if operator is a star, return A into B. Else if operator is a slash, else if operator is a slash, return A slash B. Then what I'm saying here, return which one operation? Okay, suppose I create a calc 1 equal to calculator, okay, 10 comma 5. So it means this is a calculator. This calculator function is called by sending a value and what b value. On this a and b values, what operations you want to do? So it means calculator 1 perform the operations using how many values? 2 values. So using these 2 values, how many operations I can do? 4 operations, that is adding, subtracting, multiplying, and one more is what? Division. Suppose I want to add these 2 numbers, then I'll say calc 1 of, okay, I'll try to say calc 1 of, what is the operator I send plus. So here calc 1 is nothing but operations, right? Then I called operations by sending which one? Plus. So it will add these 2 numbers. Result 2 equal to calc 1 of, I just write here what? Minus. So same data, I'm performing how many operations? Multiple operations. Result 3 equal to calc 1 of what is that? Star. Result 4 equal to calc 1 of, what is the operation here? Division. So this is a function which receive how many values here? 2 values and return one function. So here calc 1 is holding which function? Operation function. Whenever I say calc 1, it is referring to which function? Operation function. This operation function receive what? Plus. If operator is a plus, it is adding numbers. What is A value? 10. What is B value? 5. So calc 1 means it is calling which function? Operation function by sending the operator called minus. If the operator is a minus, you are saying A minus B. Then calc function is nothing but operation function by sending which one here? Star, and is returning A into B. And then again calc 1 is calling which function? Operation function by sending which one? Slash, and it returns A divided by B. So then print how many values? Result 1, result 2, result 3, and result 4. Now if you want to perform same operations on different numbers again, I create one more calculator, that is calculator 2, some 50 comma some 5, 50 comma 5, and then I do operations. R1 equal to calc 2 of, I'm doing an operation called which one? Plus. R2 equal to calc 2 of, I'm doing which operation? Star. So this is R1 and this is what? R2. So closure is a function which perform the operation using a data of which function? Outer function. Closure is a function which performs operation using the data of which function? Outer function. Performs operation using outer function. But it returns. Closure function returns which function? Inner function. And using now calc 1 is referring to which one? Operations. Calc 1 is alias. Calc 1 is alias of which one? Operation. Alternative name. Because when it return, it is assigned to this variable, and calc 1 is referring to which one? Operation. Calc 2 is referring to which one? Operation. But calc 1 perform the operations using 10, 5, and calc 2 perform the operations using 50 and 5. So that is same data, but different number of operations and then go for closures. Then you can use here closures. Then you take the help of which one here? Closures. And you can see this is the output here. Okay, right now this is how you are working with the decorators. Decorator is one special function. Decorator is one special function. Decorator is one special function. And closer is also one special function. Decorator is one function and closer is another function. And there is one more special function is there called a generator. There is one more special function is there. And what is that special function is here? Generator. Generator. Okay, suppose the name itself, right? Generator, which is used generally for generating what sequence of values. Generator is a special function which you are using it to generate what here sequence of values. But already there is a function or a data type called which one? Range. Okay, range is there. Okay, is it range will generate the values or not? Yes. For example, I want to generate the values from 1 to some 10. Then I'll say range 1 comma 11. So this will generate how many values here? 10 values. This will generate how many values here? 10 values. Suppose I want to generate even numbers, then I'll say 2 comma some 14 comma 2. This will generate even numbers 2. Okay, 2, 6, 8, 10, 12, 14, 16, 18, and one more is what? 20. Okay, suppose I want to generate prime numbers. Is it possible to generate prime numbers using range? No. Because range takes the input as what? Start. What is the syntax of range? Start, stop, and one more is a step. It will take how many inputs here? 3 inputs. One is a start value, stop value, and step value. So here the start is a 2 and you are incrementing with the 2. Start is a 2 and you are incrementing with the 2. 2 plus 2. So this is up to 12, right? So 2 plus 2 is what? 2 and 2 plus 2 is what? 4. 4 plus 2 is what? 6. 6 plus 2 is what? 8. 8 plus 2 is what? 10. 10 plus 2 is what? 12. So I can just give the difference between two values by using which one? Step. Suppose I want to generate prime numbers. I want to generate which numbers? Prime numbers. I want to generate prime numbers. I want to generate, assume that passwords. I want to generate password. I want to generate OTP number. How can I do all this? Is it range will generate all this? No. Then I have to create my own generator. So it's nothing but custom range. So generator function, actually generator function returns a generator iterator. Okay, using that you can iterate what? All the values. So generator function. Okay, generator or generator function. So what is generator function or generator? So this is Python definition of what is a generator. So what is a generator is a function which returns a function. This is a Python definition of it. A function which returns a generator iterator. A function which returns a generator iterators. It looks like a normal function. Generator iterator, it looks like a normal function. Generator, iterator, it looks like a normal function. It looks like a normal function. See this, it looks like a normal function only. Okay, it looks like a normal function. A function which returns a generator, iterator. It looks like a normal function except that it contains one keyword. What is the keyword it is having? Yield. So all the functions are not called as a generator functions. All functions are not called as which functions? Generator functions. So which functions are called as a generator functions? The function which is having which keyword? Yield keyword. The function which is having yield keyword, that function is called as which function? Generator function. Actually, a function returns a value by using which keyword? Return keyword. A function returns a value using which keyword? Return keyword. But generator function return the value by using which keyword? Yield. Okay. Generally, a function returns a value by using which keyword? Return. But generator function returns a value by using which keyword? Yield. So any function having yield, that function is called which function? Generator function. But yield expression for producing a series of values usable in what? For loop, or that can be retrieved one at a time with which function here? Next function. So generator function returns which object? Generator, iterator object. Generator, iterator. What is generator, iterator? An object created by generator function. An object created by generated function is called generator, iterator. So that is used for generating each time one value. So what is generator, iterator is an object created by which function? Generator function, and that you call it as what? Generator, iterator. An object created by generator function is called which one? Generator, iterator. Object created by generator function is called generator, iterator. So yield, what yield will do is yield expression produce a value. Produce means it return the value. After returning the value, it will pause. Each yield temporarily. Okay, each yield. Now just here, each yield temporarily suspends processing, remembering the location execution state. After returning the value, it suspends execution. It will suspend the execution, remembering what the location of state means, where it is stopped. What is the value at the type of suspending? What is the value? What is the value? All this remembered. When generator iterator resumes, it picks up where it left off. It picks up where it is left off. Now that is what each yield will do it. Yield is a keyword. It will suspend the execution of function temporarily. So yield temporarily suspends which one? Processing, remembering the location execution state. When the generator iterator resumes, it will pick up where it is left off. Now when you resume back, means when you call again, when you iterate again, it will resume and it will start executing from where it is left off. Now that is done by using which keyword here? Yield. But what return will do is, after returning value, it will terminate. Return will terminate the execution of function by returning value, but yield will not terminate the execution of what? Function. But yield will temporarily suspend the execution of what? Function. So when you iterate again, it will resume back and execute from where it is stopped. It will resume back and execute from where it is stopped. From where it is stopped. Now that is done by using which keyword here? Yield keyword. So a function can have a function which contain the yield expression. The function which contain yield expression, only that function is called which function? Generator function. So here you have to understand the notice, generator function must have, generator function must have what? Which expression? Yield expression. Okay. Generator function must have which expression here? Yield expression. If it is not there, then it is not called which function here? Generator function. It is not called as a generator function. It is not called as a generator function. Now I'm writing one function. This is called as a generator function. I'm writing one function, some function which will generate some values. Each time it will generate one value. Okay, assume that generate numbers. What is the name of this generator function here? Generate numbers. The generate numbers is a function which generate the numbers, but each time it will generate one number by using which keyword? Yield. Each time it will generate one number using which keyword? Yield. I said yield 6, yield, I'm writing yield 6, yield 9. So I'm generating each time one value, right? So I try to generate the values like this. Any values you can give, but I'm just taking the example. Now yield, okay, yield some 120 like this. Now this function is generating how many values? Total 6 values it generates. Total how many values it generates here? 6 values. So this generator function generate how many values here? 6 values. What is the first value generated here? 6. What is the second value generates? 9. What is the third value generates? 10. But then after this, now generator function returns generator iterator. Okay, generator function returns what? Generator iterator. So generator iterator equal to generator generate number. Now what this function will return is, it returns which object? Generator iterator object. It will return which object? Generator iterator object. Now how can I get the value generated by this generator iterator? By calling which function? Next function. So I want to have a first value. I'm saying generator iterator. Next of which one? Generator iterate. So it returns the next value. What is the next value generated by this function? 6. What is the next value generated by this function here? 6. What is the value 1 here? 6. So after returning the value, yield is nothing but return the value. After returning the value, will it suspend the processing or not? Yes. But when it will resume back, when you call again, which function? Next function. It will resume back when you call again which function? Next function. Now this will return another value. What is the second value? 9. And after returning the value 9, will it suspend the execution of function or not? Yes. So here I try to generate how many values here? 2 values. I try to generate how many values? 2 values. Now first value is 6 and second value is what? 9. But this is having how many values total? 6. Then I have to write next, how many times? 6 times. Okay, generator iterate. Otherwise, you can give this to whom? For loop. So next of generator iterate. Value 5 equal to next of generator iterate. Okay, value 6 equal to next of generator. Next of which one? Generator iterator. I'm trying to print value 4, value 3, value 4, value 5, and one more is what? Value 6. But instead of this, now you can see 10, 45, 78, and 1. So once it is iterated, you cannot iterate again. If you want to iterate again, you create one more iterator. Okay, some iterator 2 equal to generate number. Generate number is a function, and this function return which object here? Generator iterator object. So what you can do is you can give this iterator to the for loop. So for value in iterator 2, so where each time you are reading one value. For value in iterator 2, where you are each time reading one value. So what is that value? 6, 9, 10, 45, 78, and 120. So it means this is my own generator function. For example, now yield is there. Yield is only for returning value and suspending it, so that when you call again next function, it will resume back from where it has been what? Suspended. But return will not return. Return will terminate. After returning value terminates, but yield will not terminate. Return will terminate, but yield will not terminate. Return will terminate the execution of function, but yield will not terminate. Return will terminate the execution of function. Return will terminate the execution of function, but yield will not terminate the execution of what? Function, right? You have to understand this here. Just see. Suppose I want to write a generator function. I want to write a generator function which generates some prime numbers, right? So prime generator. What is the name of the function? Prime generator. I'll try to give the start, and then I have to give which one? Stop. From where to where you want to generate the prime numbers. From where to where you want to generate the prime numbers. So what is the input I've given here? Two inputs. One is a start. So this is a prime generator. To this I've given how many inputs here? Two inputs. What is the first input here? Start. And what is the second input here? Stop. Then I should generate the prime numbers between the start and stop. Then I've taken the count is 0, or I'll just write for number in range start comma stop plus 1. I want the stop should be included. Now each time it will read one number, and after reading a number you have to find out whether that number is a prime or not. So for I in range of 1 comma number plus 1, if number mod I equal to 0, then I'm saying count is count plus 1. You're incrementing the count with the 1. Okay. If then, yes, you are trying to count how many times the number is divisible. If the count is a 2, then you are saying yield. If the count is a 2, you are saying yield number. Okay. You are saying count. If the count is a 2, you are saying yield number. Yield is nothing but return the value and suspend the process of executing what? Function. When you call again iterator, it returns what? Next number. Okay, I'm not telling for loops. For loops are already over. Okay, how to find the prime number, you should know it, right? Already we have seen how to find the prime numbers, right? Okay. So prime generator is a function, and this will return prime iterator. Prime iterator 1 equal to, I'm saying, prime generator. So generator function returns generator iterator or not? Yes. Prime generator, I'm trying to send values 2 comma. I want to generate all prime numbers from 2 to 15. So what will happen? It will receive. What is the start value? What is the start value? 2. What is the stop value? 15. What is the start value? 2. What is the stop value? 15. Each time it will read one number and find whether that number is a prime or not. If it is a prime, then it yield that number. Okay. Suppose I want to know first number. I'll say number 1 equal to next of prime. Next of which one? Prime iterator 1. So it will return the next prime number of the prime generator. What is the next prime number of prime generator? Okay. If you run this, now you can see what is the prime number here? 2. Okay. Then you can say number 2. Next of, I'm trying to say prime. I'm saying prime I1. This will generate next number. And what is that number 2 here? 3 as a prime number. No, number 3 equal to next of prime iterator 1. What is this number 3? Now this number 3 is what here? 5. Now 2 is a prime number, 3 is a prime number, and 5 is also prime number. If you want rest of the numbers, you can say for n in what is that? Prime iterator 1, and print all prime numbers. Print all prime numbers. Rest of the prime numbers are 7, 11, and 30. So range, custom range. Now generators are like what? Custom range. Generators are custom range means you're customizing the range by creating your own generator function. By creating your own generator function. You are customizing the range and you are creating your own generator function. You are customizing the range and you are creating your own generator function. Now this is how it is. 2, 3, 5, 7, 11, and what is that? 30. So generator function should have one expression, right? What is that expression should have here? Yield. So it is nothing but your own generators here. This is generating your own values. Generating your own values can be done by using which function? Generator function. Just try to, these are special functions. These are special functions like first one is what? Decorator. Second one is closer. Third one is which one? Generator. Okay. Decorator, closer, and what is that? Generator. Decorator, closer, and one more is a generator function. So which generates some values, right? You can generate any number of values. You can create your own generator, right? So generate which one here? Alphabets. This is a generator function which generates what? Alphabets. For n in range, generate alpha. Range of 65 comma 91. I just write here yield. What is this yield? CHR of what is that? N. You must write yield, right? Okay. Then main is there. Okay. Now what I'm doing? Alpha iterator. A equal to generator alpha is a function which returns generator iterator. Now each time I'm reading one character from alpha generator iterator and I print it. So what will it do? This will generate all the alphabets. This will generate all the alphabets from A to what? Z. It will generate all the alphabets from A to Z. A to Z. Now this is generator iterator. This is generator function which returns generator iterator, and using that iterator each time you can read one value. But how it is generating the value? By using one keyword called which one? Yield. How it is generating the value? By using one keyword. There is one keyword, and what is the name of that keyword here? Yield. Yield expression. Okay. Yes. So that is called as yield expression. So this is how it generates all the values from A to Z, right? Next is these are some special functions which you write. These are some special functions which you write it, and there is one more function you can write. And what is that another function you can write is there is one more function is there, and that function is what? Lambda functions, or same thing you call it as which one? Anonymous functions. Lambda functions are what is this here? Anonymous functions. Lambdas. These are called as lambda functions. This lambda functions also you call it as this lambda functions also you call it as which functions? Anonymous functions. Anonymous function means a function which doesn't have any name. A function which doesn't have any name, and that function you call it as which one? Anonymous function. But anyway, we'll talk about these lambdas. But tomorrow we'll see how to work with this lambda functions, right? So today we'll stop it here and tomorrow we'll continue this, right? Okay.